Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 7.6. So the statement of problem is that for a given state of stress, so this is given state of stress, so you have to determine the principal plane and principal stresses. So let me write given data. So given data is that you can see the stress in x direction. This is let's your x direction and this is your y direction. Clear? So stress in x direction is equal to tensile stress, which is 2 ksi, and similarly stress in y direction, which is normal stress, is tensile, and again this is positive 10 ksi, and tau of xy. Now you can see this is plane and this is perpendicular to the axis in positive direction, but the stress is in negative direction. So tau of xy will be minus, and this is minus 3 ksi. So we will have to find the first part is, or a part is principal plane, which is theta p1 and theta p2. Clear? And the second part is that you have to find the principal stresses, that is sigma max and sigma minimum. So let's start with the solution. Clear? So as we know that for first part theta p1 and theta p2, we know that tangent of 2 theta p will be equal to 2 tau of xy, 2 tau of xy divided by sigma x minus sigma y. You have all the values, just put 2 into tau is minus 3, so 2 into minus 3 divided by sigma x is 2 and sigma y is minus and sigma y is 10. So it will be equal to minus 6 over minus 8. Clear? And that is equal to 0.750. Clear? So tangent of 2 theta p will be equal to 0.75. So theta p is equal to tangent inverse 0.75. So theta p1, here you can see that this is theta p1. Theta p1 comes out to be, this is 2 tangent. Clear? So 2 theta p is 1 is equal to 36 point, when you calculate it, it will be 36.87 degree. So implies that theta p1 is equal to 36.87 divided by 2, which is equal to 18.4 degree. So this is theta p1, and theta p2 will be equal to 18.4 plus 90 degree. There. So theta p2 will be equal to 108.4 degree. So theta p1 is equal to 18.4 degree. Clear? So this is the answer of our first part to find the principal plane. As you know that stresses are maximum on this plane, and these stresses are called principal stresses. So the next portion is to find these principal stresses, sigma max and sigma minimum. And so as you know that sigma max comma minimum is equal to sigma x plus sigma y divided by 2 plus minus under the root sigma x minus sigma y divided by 2 whole square plus tau of xy whole square. So you have again all the values you have to just put. Sigma x is 2, sigma y is 10, divide by 2, plus minus 10, 2 minus sigma y is 10 divided by 2 whole square, plus top xy is minus 3, so minus 3 whole square. And this is equal to sigma max comma minimum. Again, this sigma max comma sigma minimum is equal to, this is 12 divided by 2, and that is 6, plus minus, this will be 6 minus 8, clear, divided by 2, which is 4. So 4 square is 16, plus 9, which is 25. 9. So 9 plus 6 is under root 25. Clear? And that will give you 6 plus minus 5. That is equal to sigma max comma minimum. So implies that sigma max is equal to 6 plus 5, which is equal to 11 ksi, and sigma minimum will be equal to 6 minus 5, which is equal to 1 ksi. So these are the principal stresses. So now we will also represent them. So let this was the original element under state of stress. So this was, if you look, this were the normal stress. This was 2 ksi. Clear? So this was also positive. So this was 10 ksi. You can also take the value from here 2. This is plus y is 10, and the shear stress was negative. Similarly, it will be like this, and this shear stress was 3 ksi. So this was initial state of stress. Clear? So let this was your x direction and this was your y direction. Now I will draw it over here, so you can see, let this was your y direction and this is your x direction. Clear? So the principal planes comes out to be 18.4. So by using protractor you will take the 18.4 angle. So let's say, for example, let this angle is 18.4 degree. So this is x dash, and similarly there will be a perpendicular. Clear? This is y dash. Clear? Now from angle from this point to this point, this angle is 2 theta p, which is equal to 90 plus 18, so 108.4 degree, and this angle is theta p1. Clear? So again I will just now see. So this was your 18 angle, and this is your y, this is your x, this is x dash, and this is y dash. So again you have to rotate the element. So this will be your element. Clear? And the stress, maximum stress, sigma max, will be like that. This is sigma max, and sigma minimum will be like this. Clear? And this is sigma minimum. So sigma minimum is 1 ksi and sigma max is equal to 11 ksi, and this is the theta p1, which is equal to 18.4 degree. So you have find out the principal planes, which is theta p1 and theta p2, and again on these principal planes we have principal stresses, that is sigma x, sigma max and sigma minimum. and the value is shown over here. I hope you have enjoyed the video. If you like the video, kindly subscribe, like, watch and share. Thank you.